recently I was asked, like, can you look to this memory leak issue, why it is happening, and like, but for example, application is written on Python, right? And developers just do coding, so they said we don't have enough information.
Yes.
So I have to go to Datadog, and I have to like check different metrics, and I have no idea how to check it. That's why, like, and I was Googling, like, okay, memory leaks, how it can happen, like from application Python code or something. I mean, or for example, Sultan told me I can create a heap dump and just give it to developer, so he will do analyzing.
Yes.
But I just want to understand, for example, what to answer. Like, okay, I will do heap dump for you, like, but I want to understand why I need to do this. What is heap? At least
that's great. Okay, let's just spend 25 minutes, and I think I like talking about this type of things. So let's try to understand what does these terms mean in general. Hopefully it will make sense. I didn't have time to bring up to find some visuals, so it will help you understand. But before we go into it, let me open up our curriculum, and I'll be asking questions, and you guys, you better answer me, especially the ones who I taught, Linux. So Parvina, Virginia, Aidana, and Alexei, I'm expecting you to answer some of these questions.
About Linux?
We will talk about Linux, yes. Hold on, let me try to find, where was it? I think it was here.
Okay, I'm leaving. Bye.
That's fine.
Okay, let me try to find that. It will make more sense. Let me start asking question, what do we call a program in the RAM? I know Nursultan knows that because they're just past this topic. What do we call programs that are in the RAM? What do we have in the RAM? In memory?
Random access memory, you mean?
Yeah,
Something
RAM.
that we frequently access, like we need to get quick access.
In memory, right?
Yeah.
Okay.
It is temporary.
But what do we call the programs? Once you click the program, what happens?
It's go to RAM, to temporary storage.
So it will be loaded. This is your program that is stored on the disk, right? On the left, do you guys see my browser? Okay, you have this program which you've downloaded or you installed it through whatever, it doesn't matter. This is stored on the disk, on the SSD, it doesn't matter where, but it could be a hard drive or it could be SSD. The moment you click and open it, even if it's a Vim program, text editor, the moment you open it, it will be loaded into the RAM. And the basic idea, basic look is something like this. Once the program in the RAM, we call them processes, right? So it's going to be Linux 101. All these things, as you can see, this is the process. You see my activity monitor, right?
Yes.
Yeah.
Okay. The moment I open Zoom, this one becomes a process. We call them process. These are all the things that are running in the memory. And as you can see from here, out of 16 gigabytes of memory, I'm already using 11.41, 11.42 gigabytes. Okay? So we call them processes. And each process usually will have something called heap and stack. This is where whenever you create a variable like this, you call zeros, you call ones, whatever. Those are usually, at least in terms of Java, they are created in the stack area for this process. Whenever you create some object, strings, right? String is an object here. It's not a primitive. So whenever you create something like this, or you create another object from class, all those are stored in the heap area. Are we clear so far?
Yes.
Okay. All those are heap area. So when they say heap dump is basically a snapshot of your process running at given time. It's like you're taking your camera, photograph machine or whatever, you are taking a picture of the current state of that process. So in this case, my Chrome browser is now working. If I did heap dump or something, it will give me the heap status, the how much memory and how much whatever it was consuming at that given point. Okay, it's not real time. That's why we say snapshot. Took a picture, that's what you have. So far, does it make sense?
Yes.
That's what we mean by heap dump. When you do a heap dump, you will get a snapshot of the current state at that point for the process. Usually heap dumps are in binary format, and we have special programs to be able to analyze that data. Once you have a, let's say Paulina took a heap dump of the running process in Python, and she provided all this data in binary format. I think in Java it's .hprof or something like that. We get that data and we analyze it using some special programs. I'm pretty sure Python has its own. Because it's in binary, only those programs can, you upload it, and those programs can show you what was the state of your application when the snapshot was taken, the picture was taken. And you can analyze if there were some spikes, if it was consuming a lot of memory, meaning heap. You might have a lot of objects in here. Let's say you were expecting to see it to consume, let's say 500 megabytes or something, but for some reason it was 2 gigabytes or something like that. That's how we usually analyze the data. I'm just oversimplifying it, really oversimplified version. But it is okay to see spikes. Why? When you are seeing that a lot of users, let's say they're using your web application, right? It is okay to see those kind of spikes because a lot of people requesting something from your server and your application is basically serving those users. But it's not okay after the users left your web app. It's not okay to see those spikes are still there. So it should go gradually down. That's where the garbage collector comes in. Now we're talking about another term that Paulina mentioned here, garbage collectors in here. In languages like Python, Java, Go, we have something called garbage collector. As the name suggests, it will collect the objects from the heap area if it decides it's not being used anymore. Memory leaks usually is pretty prevalent and it's pretty popular in languages where it doesn't have a garbage collector. Garbage collector automatically frees up the memory that are not being actively used. Okay. In languages like C, C++, developers have to manage their memory usage themselves. The moment we did not need this array here afterwards, after we're done, in C and C++, you have to manually release those memories. If we had 10 items here in C, C++, you say, I'm gonna need 10 bytes or whatever space, meaning I want to allocate memory for this array here. Once you are done with this, you have to release it as a developer. Sometimes we forget, sometimes from other means we tend to forget to release that. That's how you get usually a memory leak, meaning it will start consuming a lot of memory in this area. What was it? In here. And since you don't have a garbage collector, which automatically cleans up after the developer, that's the state you don't want to be in. Okay. So probably that's why they asked you to get a heap dump of the application running its running state. And we usually take the heap dump when we know there's a spike in the application. How can we find out which process is consuming a lot of memory? Aydana, Parvina?
HTOP, yeah, with a
From
command.
HTOP, top command, or you can look into the proc. Well, if you just cat out /proc/meminfo, it will give you the overall information about what's your RAM usage, what's your free space in your RAM, right? But with htop top, you can find out which process is consuming how much memory. Is that right?
Yes, and CPUs and load balancers.
Yeah, load average, not
Yeah.
balancer, but load
Oh,
average.
yeah, load average, yeah.
Okay. That's how you can find out if it's consuming too much memory than expected. You know that the developer usually should know that it's consuming too much memory than it's supposed to. At that time, maybe it makes sense to get a heap dump and analyze. But from DevOps perspective, SREs, or it doesn't matter, I don't think you need to do anything. Maybe if they don't have access to the application, or if it's in the container, I'm not sure how you do that. It might be your responsibility to get the heap dump of the application. Right, Polina? Was that the case in your case, in your situation?
I mean, not yet. I did not do it yet. I'm
Oh.
just still looking to Datadog, diagrams
Yes.
and just checking it. Yeah.
Okay. So basically, that's the idea. Let me go back to Slack now. So did you guys understand the memory leaks and garbage collector? What garbage collector does?
Yeah.
Garbage collector, it's a too technical topic, but in Java and I think in Python as well, we have different garbage collectors, which will do generational sweeps, meaning it will put the objects that were just created and it will mark them as a new generation. From time to time, it will mark them as an old generation. If it doesn't find any references, any variables pointing to the memory location on the heap, it will assume it's not being used and it will start cleaning up the memory. It will release the memory. Does that make sense? In a nutshell?
Yes.
Okay, that's what garbage collector does. There might be generational garbage collector, and there might be the other one. I forgot the name for it. It doesn't matter, but I don't remember exact name. Generational, and there was one more. Java has a lot of those, a lot of types of garbage collectors. Okay, memory leaks. That's why it's important to, if you guys remember, I told you in the Python class, it's important to release the resources. What could be the resource? Do you guys remember? Parvina? In Python?
Say again, what's the question? My daughter just opened.
What can we consider as a resource? What I said that we need to make sure that we release them. Aidana?
After we install something?
Not install, probably. Polina, do you know?
You mean those lists which we're using strings, which we allocate when we initiate our functions? You mean that or no?
Not that, but when we say resources, it could be file, right? You open some file, let's say.
Okay.
So it's a good idea to make sure that you actually properly closed it. That's why you need to have a proper, when you are opening a file, you need to have a proper try except blocks, that finally blocks, that you make sure that the file is actually closed, so you don't consume the resources. Also, when you are making any API calls or anything like that, you actually create one of those handles, right? Which makes use of the thread or whatever, using HTTP, any client. I'm not sure what it is in Python. So you need to make sure that you actually release those database connections. If you opened up a connection to a database, you need to make sure that you are releasing the resource. Your resource is what in this case, Paulina?
Connection string?
Not the connection string, but actual connection, right, to the database.
Connection.
Serge?
Can you explain here? So you create a connection to database and you need to do some query in database. So
You
after
create a
you're done with this specific task, you have to log off from database, you mean, and close this connection.
Yeah, you need to close the connection. You need to make sure that you're closing the connection properly. It's especially probably important in the case of the scripting. I'm not sure from the DevOps perspective how much time you guys actually do any database connections, but in the applications, so that's the difference between the scripting and the application, right? Usually, scripting, you have a script file. It's usually short-run program, right? You run your script, it does something, and it turns off afterwards, right? But the applications like written in Python or Java, they're always running, and they're serving files or whatever requests that might come in from users, right?
Yes.
In those situations, we usually maintain database connections because every time opening, closing the database connection is costly. That's why we say we want to maintain at least 20 connections so that we have them available whenever we need it. So we keep that connection open. We don't close those. But we say that the limit should be, let's say in our case, it will be 300 connections can be created whenever it's needed. We actually had this issue like 2 or 3 months ago where our application was running into an issue. It was creating connections, 300, but it was not releasing the connection. And it was running out of the connection because we set the limit at a 300. And those connections that were created and requested by some piece of our application, it was not releasing them back to the pool. We say pool, where we maintain some connections, let's say 20 of them. All these code that were requesting database connections, they were not releasing it back to the pool. And since we've already created 300 connections, our code will not create any new connections because that's the limit that we have set. And we were running into issues in production where it was spinning for the users and it's not returning any answers because it was not able to get a new connection. Basically, our application was not able to query database to get the information that the user requested. This is a pretty tough one to spot, but thankfully we had logs and we saw that connection counts that were created was going up, but they were not going down. Why? Because it was not properly handled. It was not releasing the connections. Does that make sense?
So what was the reason, like garbage collector did not work correctly, or you have to manually release resources?
Yes, the developer has to release those connections once it's done.
Okay.
Once it's done, they're using, let's say one piece of code, which let's say gets employee data. That piece of code was getting the connection request. It was getting the connection, but then it was not releasing it back to the pool. So there were no available connections. As a result, the database connection pool was creating new connections until it reached the 300 level. Once it's hit that 300, it's not going to create anymore.
In order to analyze that, we can have some tool which will go through the code and it can give us like possible places in code, right? Or no, where it like handled not properly. Like
so that will be the topic of developers, and usually in IntelliJ it might tell you that this resource is not being released back. It might give you a clue, but from DevOps perspective, I don't think you will see it. The database administrators, they will see it on their end, how many connections were already consumed, and they will see how many connections are already opened, basically, let's say from your application.
Okay.
That's what it means. The garbage collector is usually mainly for the heap to release the memory that is not being used anymore. And memory leaks is kind of related to this. Sometimes it will not be able to tell if it there are topics like weak reference, strong references, and all that. Depending on those kind of things, garbage collector will wipe it out or will not wipe it out if there are still some references to that memory location. I think it's a good enough information for now, but in the future, if you guys want to know more, we definitely can talk about this. Dependencies. We have 4 minutes left, but let's leave this dependencies, packages, and what else do we have? Heap dump, we already mentioned. They might ask you to get the heap dump, and usually I think they will give you the command or whatever needs to be run to be able to get that heap dump, okay? PyYAML, I think you were mentioning it here, right? PyYAML, I think it's a package which converts, given the YAML file, it will parse it and it will give you back whatever you have in YAML file as a Python object. I think that's what it does. Pip is I think this is what do you call it? Package manager for Python applications. We will see this in the next time we talk, okay?
Yep.
But just shortly, let's say you have a Python application and it has let's say 100 dependencies, package dependencies. Maybe you are using some parser from a developer from company, or your Boto3 could be a dependency as well, right? So whenever you install all of this, the folder, your application might be 1 gigabyte. So you don't want to, let's say if I needed the same code, you don't want to send me the 1 gigabyte file. Instead of that, you can have a file where you will list all the dependencies that this particular application needs to be able to actually work properly, right? There will be some file where you will list all the dependencies. So all you need to do whenever you want to share your application with someone, package your application without the dependencies downloaded. You only need that file where the dependencies are listed. Instead of sharing 1 gigabyte file, you will share with me maybe 20 megabyte file. And I open up that folder directory and I just do pip install, let's say. It will analyze that file where you've listed all the dependencies and it will install all of them. And at the end, I will have a 1 gigabyte as well. So we don't have to share the huge files. Whoever needs to do it, they can just run pip install, let's say, and it will install all the dependencies, packages that the application needs. Does that make sense?
Yep.
Okay. We can see this in action next time if we meet. Okay. Do you guys have any questions? We have 1 minute left and we have students here already. They want to learn Linux.
Oh, batch 12?
Yeah, batch 12.
Nice. And regarding the garbage collectors, I did quick research and you said like generational and another one might be incremental.
It could be incremental. I think there was one more. I don't remember exactly.
Concurrent.
Concurrent as well, yeah. Python, garbage.
Yeah, I put a 6 or 5.
Exactly, yeah. There are different types. Probably we can find it from images. So this is what we call, there might be a garbage collector called, like in Java, we have mark and sweep garbage collector, concurrent garbage collector, different types, which will, why do we have different types? They will do the wiping, swiping, or cleaning up differently as opposed to other ones. So generation will first mark it, concurrent will be doing something, but let's get into this next time.
Okay, thank you.
Okay. Yes. If you don't guys have any questions, I'm gonna stop. Okay. See you guys. I have to stop it.
Thank you, sir.
Alright.
Bye bye.
Thank you.
Yo, bye bye.